Hello everyone, we're back to chain rule 3.6 chain rule. This is the bigger thing in calculus. And remember, chain rule, we have a formula. Let me try to roll down a little further. Yeah, we already introduced the formula for the chain rule, right? dy dx can be found as dy du times du dx. Okay, this is really the formula for the chain rule. And we did one example in my first part of the video. It is for the derivative of this sine function. And also, I hope you recognize it is in the fashion of sine of x cubed. And we realize this is really not the basic sign as we learned before. If it is only sine x, we can get a derivative. But also we know if it is sine u, we could get a derivative in terms of u. It's cosine u. So I did a trick. I simply created a notation u for x cubed. Indeed, in terms of u, the function y, it just tends to be sine u. So I got the derivative of cosine u. But anyway, I hope this time you see it clearly. This is really dy du should not be the same as dy dx, right? Right. So I did not answer the question if I end here. But I did the other part. U is created as a function of x. So I do know du dx. And then indeed, this is what the chain rule says. You always can find dy dx as the product of dy du dx. Okay, so that's what we did from last time. If you have any questions, do send me email or feel free to join those online sessions. Okay. And then we are going to do a little more about, well, maybe a lot more. There's really a lot more about chain rule we need to consider. So the next example, indeed, it is the example on the textbook, 3.49. 3.49, and I put my example first and then the example on the textbook. I just want to make sure first, really, I suppose you see the function here is different from the one we just talked about, right? Sine x cubed. Roughly, we can read it in the same fashion. So this time to read it correctly, I will have to say sine x, the entire thing with parentheses to the power 3. So I do know if I only have sine x, then the derivative would be cosine. The issue is what would happen? Well, how do we handle situation when we have sine, the entire sine part written to the power 3? And now with the chain rule in mind, I know I always can create a notation, replace a bigger part with a single notation. So this time, the notation I'm creating here, u, it is just for sine x. And then I realize when I create u for sine x, so the function y actually it is not a trigonometric function anymore in terms of u. It is u to the power of 3. Anyone remember what is the type of the function here? It's not a trigonometry, right? And it is a power function. So I really want to say for y, for the derivative in terms of u, we can get the derivative from the power rule, 3u squared. And also, like we did in the previous example, for the notation we created, it is a function of x. So there's derivative with respect to x, which is cosine x. And then again, this indeed, it is the chain rule formula. dy dx is dy du times du dx. A lot of these, but anyway, I say you want to understand this is a product of two derivatives. And also the way to help remember the formula, as I'm saying, dy du, it's not separable. Du dx still not separable because it is just for a single derivative. But anyway, when you write them together, maybe it looks like it's reasonable to assume somewhat du is cancelled. And indeed, it is just true. you multiply them together correctly, it just turns to be dy dx. That's all about the chain rule. Okay. And then you put everything back. We already calculated those two derivatives. 3u squared for dy du, du dx, that's cosine x. So I'm having 3u squared times cosine x. I'm not very happy. Well, actually, I'm happy with this answer, but I'm a little confused if this should the point should I stop or that's the end, because the problem we are having here, it is all about x. U, it is the temporary notation. So I guess in the end, you are going to remove the temporary notation. U, it is for sine x, so I replaced it with U as sine x. Certainly U squared, it is sine squared, and then still have cosine x in the end. Everything in terms of x. Indeed, this just turned out to be the correct derivative of the function y equals sine cubed of x, y equals sine to the third power of x. Chain rule, chain rule. This is the formula for the chain rule. This is the formula for the chain rule. But let's work on a little more examples with trigonometric functions. Besides those two examples, somewhat are similar, though really seriously they are different. Okay, they look alike, but anyway, they are really not the same thing at all. How about work with some? I'm not sure it's simple or I guess nothing simple or easy in calculus. Anyway, let's work on another example on the textbook. Example 3.48. We want to calculate the derivative of h of x, 1 over 3x squared plus 1 squared, a lot of squares. And first, what I did here is I simply take out the base of the denominator as u. And if you ask me the reason why, because when I take the base as u, this h could be considered 1 over u squared, right? And also, I suppose you do know when we say we have something 1 over u squared, it is really a power function u to the negative 2. In other words, as I'm saying, I can calculate the derivative of this h with respect to u using the power rule. And also, this is derivative I calculated. And at the same time, I have u as 3x squared plus 1. Also, I can calculate du dx. And the du dx, it is 6x, right? And then this time, the derivative we are considering, it is for function h. Certainly, you can use the prime notation because it is clear. This h is a function of x, so the derivative should be dh dx. H prime, it is dh dx. Okay, maybe I'll add a little more here to make it clear. The derivative we are working on here, it is dh dx. Or even though I calculated the two derivatives already, but I suppose you see they are not the same. But they are very helpful. If I multiply them together, dh du, du dx, the product just turns to be dh dx. Okay, and like the thing you may expect, if you just simply multiply them together, replace each derivative with the actual calculation, you always got a mixture of u and x. And usually we do expect an answer in terms of x only. So I replace u, get u back to 3x squared plus 1. To the power of negative 3, it is to the power of 3 in the denominator. And also I have these other terms combined. Negative 2 times 6, negative 12x. That is the derivative. That is the derivative. That is the derivative. Derivative calculated using the chain rule. Using the chain rule. Okay, let's give another try. And this time it is the checkpoint from the textbook, checkpoint 3.34. It is to find out derivative to the power 4. And also, I want to know, if you don't mind, if we only consider something relating to the power of 4, you could expand this into the polynomial. But take a quick look, okay. Inside the base part, we have a third degree polynomial, right, to the power of 3. Then raising to the power of 4, basically, if you just want to multiply this out, it would be polynomial of degree 12, right? 3 to the power of 4, that's 12. So there will be 13 terms. And besides, I really don't know, or really, I do know it's very much complicated if you multiply those 3 terms out 4 times. So this is really not the way we want. We are going to consider chain rule. And like I did before, this time I created a notation for the base, u as for the base. Because it is clear when you have this part as for u, then h, it is u to the 4. And then we can calculate the derivative of h with respect to u, dh du. That's from the power rule. And also, we can calculate the derivative du dx, mostly actually, again, this time it is for the power rule. Okay, so 6x squared plus 2. I think I should be all right. Du dx, dh du, we got 2 derivatives. We want to have derivative of h of x. H, it is a function of x, so h prime of x, really it is dh dx, which is not the same as either one of these two. But when you multiply them together, still take a quick look if it makes sense. Kind of like the situation du is cancelled. So indeed, I'm convinced it is a good arrangement. It is the correct arrangement here, okay. So we are having everything in terms of x, because this is a 4 times, I have this part combined. 4 times, I take out the 4 to the front, 4 times 6x squared plus 2. Then u to the 3, u is this part to the 3. I skipped some writing, hopefully it's easier to follow, right? Let's keep on trying. The chain rule. This time it is derivative of cosine h. It is cosine of 5x squared. It's not cosine single x or cosine single u, cosine single t, but we can make it happen. Okay, when I create a notation u for 5x squared, h of x, it just turns to be cosine u. So I can calculate dh du. And also at the same time, I suppose you can do the same. That is du dx. Then according to the chain rule, we just need to multiply the rule derivative together. And still just make sure we get the arrangement correctly, look closely. dh du times du dx, kind of situation since du is cancelled, right? So indeed it is just dh dx, but you really want to understand that this only help, okay, I say du is cancelled, it only help understand the situation or remember the formula, but there's no cancellation at all here, okay. And then when you understand the formula, you could put everything back to match each term in the formula, dh du and du dx, and in the end, you always get back to x. So this is the derivative. This is the derivative from the chain rule h prime of x. And the chain rule has a formula. This is the formula for the chain rule I present. And also there are equivalent forms, at least there's one equivalent form on the textbook. But anyway, somewhat I feel this might be a little easier to follow. So I'm just going to present the formula for chain rule in this fashion. If you know there are other ways, if you feel comfortable with other ways, feel free to do your own way. But anyway, I really want you to know there's only one way. The other way, or the way I present, must be equivalent, So that's the topic for chain rule. Thank you for watching.